In this video, we will look at functional dependencies, which is an important concept that we'll be using in our normalization process later on. So let's start with some definitions. What we mean by a functional dependency, it means that the value of an attribute will determine the value of another attribute in that relation. So for example, if we have a student ID, the student ID will determine the name of that student because the student ID is unique in our relation. So a functional dependency, again, the value of one attribute will determine the value of another attribute. Another definition we'll look at is the candidate key. A candidate key is a unique identifier. It's unique in our table or relation. And one of these candidate keys will become our primary key. So when we look at our relation, we might have some candidate keys, multiple candidate keys, and one of them will pick to be our primary key. So for example, if we have the credit card number and the social security number in a table, we can consider both of them as candidate keys because our shopper will have a unique social security number and each credit card is only assigned to one shopper. The credit card is unique for the shopper. So we can actually uniquely identify our shopper using either the social security number or their credit card number. So we can consider both of them as our candidate keys. Each non-key attribute in our relation will be dependent on each or on every candidate key that we have in that relation. So the name of the shopper, their age, their address, they all depend on the value of the social security number. Once we know the social security number, these other values or attributes will depend on that social security number. Same thing if we consider the credit card number as a candidate key in that relation. So if we say that x determines y, that means whenever we have two tuples with the same value of x, with the same value of the attribute x, they must have the same value for their attribute y. So if we have two tuples, tuple 1 and tuple 2, in a relation instance, if we have tuple 1, the value of x is equal to the value of x in tuple 2, the value of y in tuple 1 will be equal to the value of y in tuple 2. And where do we get these functional dependencies? We are actually getting them from the constraints that we have on the attributes. So when we say that the credit card number is unique in that relation, that means that the credit card number will be a candidate key and anything in that relation will depend on that credit card number. If we say that the project number will determine the project location, that's another functional dependency that we have in that table. And again, these functional dependencies are coming from the constraints that we have for that relation. So let's look at some examples to make this a bit clearer. If I say that the social security number determines the employee name, that means the employee name has a functional dependency on the social security number, and that's how we map it. So SSN determines the value of employee name. If I said that project number determines the project name and the location, so the project number will determine multiple values, so we can have these values inside these curly braces. So the project number is determining the project name and the project location. We can have it on the other way too. So if we said that the employee's social security number and the project number together will determine the hours per week that the employee is going to work on the project, we'll have the composite attribute or composite key in here, social security number with the project number. They both together determine the hours. So the social security number on its own does not determine the hours. So we can have the same employee working on two different projects, but for the first project he's spending 5 hours, for the second project he's spending 7 hours. So notice that the value of the hours is changing with the same social security number. However, if we have the social security number with the project number, in that case, both of them together will determine the hours. So again, the functional dependency is a property or a constraint that we have on our attributes in the schema R or our table or the relation R. Now, when we have this constraint must hold on every instance of that relation. So whenever we populate that relation, whenever we populate that table, all the rows in that table must hold that constraint. So if we have x functionally determines the value of y, if we have x equal to 1, every time we have x equal to 1, the value of y will be the same. Every time we have the value x equal to 1, the value of y will be the same. So if we also have a key in our relation, since the keys are unique, they will not be repeated in our table. That means we have a functional dependency, and k functionally determines all the attributes in R. Why? Again, because if we have a tuple 1 that has the value k in that column, we cannot have another row with the same value in that column. So to be able to define these functional dependencies, we need to understand the meaning of our attributes in that relation, and we also need to understand the relationships between them. So just by looking at a partially filled table or an instance of a table where we have some rows filled, we have some tuples populated, it's going to be hard to determine if we actually have a functional dependency. All we can conclude is that we might have a functional dependency between certain attributes. Why? Because we might get another row, we might populate our tables with another row that does not apply that constraint. So what we can conclude by looking at our filled or populated relation is that we might have a functional dependency between certain attributes. What we can certainly conclude is we can say that we do not have a functional dependencies between some attributes. So if we see that we have an attribute x and we have the same value for x repeated twice or more than 2 times, so x was equal to 1 multiple times, but the value of y was not the same for that value x, in that case we know that we do not have a functional dependency between x and y. So we can definitely conclude if we do not have a functional dependency between two columns if we have a violation in these tuples of these dependencies in our relation. So let's look at this example. We have a table called teach, and we have these 3 columns: teacher, course, and text. And this table is populated. We have this as an instance of that relation. So at a moment in time, we have this data in our table. Now, again, we cannot say that we have a functional dependency. We can say that we might have functional dependency between 2 attributes. So if we look at the text, for example, in here, we see that whenever we have Bertram, we are getting data structures. Since we do not have a repeated value of that text, we can say that Bertram is determining the course data structure. Same thing with Martin. Martin, we are only getting data management when we have Martin. When we have Hoffman, we have compilers. And when we have Horowitz, we are getting data structure. So we are not, whenever we have this value of text, we are getting the same value for the course. So whenever we have Bertram, we are only getting data structures. And we are getting this functional dependency because we do not have any repeated values. Again, we will say that we might have a functional dependency between the text and the course. Why do we say we might? We do not say we are actually, or we cannot conclude that we have a functional dependency, because we might add a row in this table, for example, and with the text Bertram, and the course could be another course. So in that case, Bertram is not determining the course. In that case, we do not have a functional dependency. But just by looking at this data, we say we might have a functional dependency between the text and the course. What we can actually conclude is if we do not have a functional dependency. So when we look at the course data structure, we are not only getting Bertram, we have data structure with the text Horowitz. So the course is not determining the value of the text. Same thing with the teacher. Smith is not always teaching data structures. Smith does not determine the course. So Smith could be teaching data structures, or he could be teaching data management. So the value of the teacher is not determining the value of the course. Same thing with the course. The course is not determining the value of the text. So data structures is not always getting the textbook Bartram. We might be having data structures with the text Horowitz. So the course is not determining the text. So all these 3 functional dependencies are ruled out. We do not have functional dependency between the teacher and the course. We do not have functional dependency between the teacher and the text. and we do not have a functional dependency between the course and the text. Why? Because we got at least one value that was not the same for the same value x. So teacher, we have Smith. We are not always getting data structures for Smith. We got data structures for Smith. We got data management for Smith. So again, the teacher is not determining the course in this example.